today we're going to talk about circles, and we're just going to get the basics of circles. And we need to know some vocabulary about circles, and luckily throughout your years of schooling you've probably learned many of these terms in the circles. And the first one is a circle is the collection of all points in the plane that lie a fixed distance from a fixed point known as the center. In this particular circle that we have, so in terms of this definition, what happens is A is the center of the circle, and all of the points that make up the circle are the same distance from the center. So this point here, if I can get that on the circle, is the same distance as this point here, from A to this point, A to the green point, from A to the red point, from A to the blue point. Those all have the same distance. And in a circle, there's 360 degrees, and we name a circle by its center, and I didn't do very well with my space, but this is circle A. That's how we name that circle. And as you're writing that down, we can talk about some more words. Again, one that you should be familiar with, which is the radius. And the radius is a segment drawn from the center of the circle to any point on the circle. So if we start with the blue from here to here, that's a radius, because we went from the center to a point on the circle. But we've got many radii, that's the plural for radius. There's another radius. And we can also do the red here, that is another radius. There are an infinite set of radii on the circle. A chord is a segment that has both its endpoints on the circle. And as I flip my page here, but as we look at the next page here on your circle, a chord in this case, it has two endpoints on the circle. So in this case, D and B form a chord here in the circle. So again, a chord is a segment that has both of its endpoints on the circle. And then a diameter is a chord that passes through the center of the circle. It would have both endpoints on the circle, so it is a special chord that spans the entire length of the circle. Again, you're familiar with that vocabulary. If we take a look at this picture that we just a moment ago looked at in terms of chord, it says list 3 segments that represent the radii of circle A. And I'll start with one. It's going to be AB. And remember the symbolism for segment is a line. And some of you put 2 dots at the end of the line. I don't spend my time doing that. But AB is a radii. And some of you can probably work ahead and get 2 more radii. Another radii or singular radius is AD. Again, notice it's a point on the circle to the center of the circle. And thirdly, we have AC. Those are all radii of the circle. Segment of the diameter. The diameter is a chord that spans the entire length of the circle. So we've got a point here and a point there, and we go through the center. That's really important for the diameter. So we can give that segment as DC or CD if you prefer. And then all chords that are currently drawn in here, well, again, the diameter is a special chord, so DC, and there actually is one more chord, which we saw a moment ago, and that chord is going to be DB. It just has its endpoints on the circle, and then we're connected there, and it's segment DB. And chord might be one of those terms that you're not familiar with. Some more vocabulary here. An arc is part of the outside of the circle that's created by two distinct points. And I'll go back and use our previous circle in a minute, and you might want to highlight it. That's what I'm going to do. But a semicircle is an arc that is half the circle. So if the entire circle is 360 degrees, then half the circle is going to be 180 degrees. And when we go back to our previous, when you look up here, here is an arc of the semicircle. So it has the endpoints at the diameter. We could have drawn from point D over to point C in the other direction. That is also a semicircle, but there's the arc. You can see the curve in that. We also have in our words here, minor arc. And a minor arc is an arc that's smaller than a semicircle. So it's less than 180 degrees. And that's what I say in my next statement here. It's between 0 degrees and 180 degrees. But it has to be more than 0. And it has to be less than 180 because it has to be smaller than a semicircle. So if we look at a minor arc in our previous example here, a minor arc that just turned green, not what I wanted, but try it one more time. Here's a minor arc. We don't know how many degrees it is, but it is less than a semicircle. So that's a minor arc. Consequently, a major arc would be something that goes from here to there. And you can probably infer from that an arc that is larger than a semicircle is going to measure between 180 degrees and 360. It has to be more than 180 degrees, but less than 360 degrees for a major arc. Minor is between 0 and 180, major is between 180 and 360. So if we look at example number 2 here, it says in the diagram below, points A, B, C, and D all lie on the circle. This is circle O because that is what the center of the circle is. And it says name 2 semicircles that are in circle O. And when we name semicircles, we use 3 points to do that. So semicircle, we can say is arc. So here's our symbol of arc. It looks like an arc. And we could say D, A, B. Or we could go the other direction, and we could still start with D, but we could say that it's arc D, C, B. And what I'm pointing out here in terms of identifying the semicircle is we need to pick a chord where there's a diameter. So it's a chord that goes through the center of the circle. Those endpoints, notice whether we go kind of up to DAB or whether we go down to DCB, the endpoints of the diameter end up to be the endpoints of the arc. If we name 2 minor arcs in circle O, when we name 2 minor arcs, we only use 2 points. and we still use that symbol of an arc, there's lots of them that we could say. We could say arc DA, or we could say arc AB. We could say arc BC. Like I said, there's a lot of them. We could say arc BC or CD. That gives you at least a sample of them. There's probably more. And finally, a major arc. Again, a major arc is between 180 degrees and 360 degrees. We use 3 points when we identify a major arc. And our symbol for arc is still going to be kind of a curved looking arc. And when we name a major arc, remember it needs to be more than a semicircle. So we might say how about DBC? DBC. Takes up almost the whole circle. Or we could say something like arc CBA. CB, and we stop over here at A. And it says name 2. There's probably more, but that at least gives you an idea of a major arc. Again, let me point out, semicircle, you use 3 points to identify a semicircle. Major arc, 3 points to identify a major. Minor only takes the 2. As we flip over, the tangent is a line which, no matter how far it's extended, intersects a circle exactly 1 time. In the diagram shown, line M is the tangent line, and it's tangent to circle O, the name of the circle, at point A. So this line, line M, only touches the circle at point A. The thing about this is that a tangent line is always perpendicular to the radius of the circle. So if we drew this in, here's the radius, I tried to draw it in. What happens is that it hits at a right angle. And then what types of angles are formed by perpendicular lines? Well, I give it away by answering that question by drawing it in already. It forms a right angle. So when we look at an example here, in circle K, segment AB is tangent to the circle at point A. And again, from what we were just talking about here, we've got a good picture. That means that that's a right angle right there. Even before I read the rest of the problem, in circle K, AB is tangent to the circle at point A. If the radius of the circle has a length of 5, so this is a length of 5, and the tangent has a length of 12, so that's our segment AB. What we want to do is we want to find the length of KB, but when we see a right triangle in this problem, what we should automatically think is Pythagorean theorem. And that's what we're going to do. I'm going to call this length C, and we're going to set up 12 squared plus 5 squared equals C squared. Side squared plus side squared equals hypotenuse squared. And that length of C is the hypotenuse. It's a cross from the right angle. 12 squared is 144. 5 squared is 25. If we add these two together, we get 169 equals C squared. And remember to undo the squaring. We're going to take the square root. And you can use Desmos, you can use your calculator. Either way, what happens is we find out that our length of C, which is really our length of KB, is 13. And finally, in a circle, a radius or a diameter of a circle is perpendicular to a chord. Then it bisects. And I think it says in a circle, if a radius or a diameter of a circle is perpendicular to the chord, then it bisects the chord. So our radius is length AD in this picture. Our chord is CB, and because it's perpendicular, you can see a small, very light right angle. That means that this length is congruent to that length. And that's what I say. BE is congruent to CE, because again, it bisects the chord. And not only does it bisect the chord, but it bisects the arc. So if we look at an example to finish, it says in the diagram below, BE is perpendicular to AC. So this is, and I want a different color here. This is a right angle here. And it says AC is 16. Well, because it's perpendicular, even though this entire length of AC is 16, we can bisect that. It cuts that in half. So half of 16 is 8. We also know that BD is 6. And what we want to know is well, how big is the length of AB? And it's going to be the same idea here. We've got a right angle, and we've got a right triangle, in fact. And what we can say is, 8 squared plus 6 squared equals C squared, which is 64 plus 36 equals C squared. And 64 plus 36 is 100 equals C squared. And again, use Desmos if you need to. Use your calculator if you need to. But we're going to take the square root of both sides to find our length here, which I called C. But ultimately what we were really looking for is find the length of AB. And that's going to be the length of AB.